Hi, in this video I'm going to explain very quickly what is chain of responsibility pattern, and I will show an example in Go. So according to Wikipedia, here you can see in object-oriented design, the chain of responsibility pattern is a behavioral design pattern consisting of a source of command objects and a series of processing objects. Each processing object contains logic that defines the type of command objects that it can handle. The rest are just passed to the next processing object in the chain. So to give an example of what this means, let's say we have a request. Okay, let's say like an HTTP request or something. So a request is usually handled by handlers, and there might be various different handlers, each do their own specific tasks, right? So there can be handler A, handler B, handler C, and in the chain of responsibility pattern, we pattern these handlers in such a way that they all look at a request, do whatever they have to do, and then pass it on to the next handler in the chain, and so on. Okay, and then once a particular handler which can actually address this request, then it will handle it and do its work. Okay, so a real world analogy of this chain of responsibility pattern can be, let's say, a customer call, where you call a customer care of a company and you have like a tier 1 support, tier 2 support, you get rerouted across various calls and finally find the right person who will actually handle your call, right? So there can be similar other examples as well, like in case of office approval chain, different departments are there for different levels of financial approvals that you might be looking at. Okay, so the key characteristics here are decoupling. So the sender doesn't know which handler will process the request, but it allows us to be more flexible because handlers can be added, removed, or reordered without changing the sender. It also takes into account the single responsibility because each handler does one specific thing, and it also supports short circuiting, so a handler can stop the chain if required. Okay, and in this example I'm going to show some HTTP middlewares which act as these handlers. Okay, so what is a middleware is some code that sits in the middle between a request and its final handler, right? So in case of web applications, you might have an HTTP request and it may have several middlewares. So one middleware might be through logging, another might be doing authentication, another might be checking rate limits, and then finally the final handler gets reached, which actually does the business logic. Okay, so in this case, this is the chain of responsibility pattern here. So in the form of various middlewares chained together. Okay, so in our example, we will simply chain together three such middlewares. So I will now go through the Go code and then I will execute that Go code to show how it works in practice. So here, this is the file, and here I have this main function. So what I'm doing here is eventually I'm creating an HTTP server. Okay, this serve dot listen and serve, and what this is about is we are having certain endpoints here, and these endpoints are handled through this public chain or private chain. And what are these? So this public chain is a chain of these three middlewares. Okay, so the public chain is for routes that don't need authentication. So a request comes, then it goes through request ID, logging, recover, and then handler. A private chain, on the other hand, it might need some extra stuff like authentication or rate limiting, right? So these two are added in that chain. Okay, so the idea is that when this endpoint is hit, then the request will pass through all these middlewares before hitting the actual business logic. In this case, there is no actual business logic, but these middlewares as handlers. Okay, and where is this chain defined? The chain is defined here, where it takes a series of middlewares and gives a middleware as a return, but it actually applies those series of middlewares on the handler. Okay, so here, so the chain gives a middleware as an output. And what is a middleware here? So middleware is a function which takes an HTTP dot handler object and gives an HTTP dot handler object. Okay, so What is a middleware? Middleware is a function that takes this handler, returns an handler, and it applies those middlewares in certain way. So the ordering matters here. So let's say the middleware A runs first, then B runs, then C runs, then the handler runs, then C finishes, B finishes, and A finishes. Okay, and I will show you here the actual middleware functions here, the ABCs. So middleware number one is the request ID, to which is used to assign a unique ID to each request for tracing or debugging. So here is this request ID function, which also returns a function. And before it returns, it does its own work. So its work is to get this request ID. So it gets the ID here, it does some checks, and it's adds the request id to the journey. Okay, and it sets the header accordingly, and then it passes it on to the next handler. So here it passes it on by calling this next dot serve http. Okay, similarly middleware 2 does the logging. So it does some initialization, then calls the next handler, but then it also logs certain important information it after it is done with the next handler. Okay, so uh, here it uh, here it logs things like times, how much time it took, and client IP, color, etc. Similarly, we have this recover middleware, which what it does is it catches panics and converts them into 500 errors instead of crashing. Okay, so here what it does is it simply has a defer function, and it simply calls the next handler, and in case it panics, this defer is going to run, and here inside this defer there is this recover function. Okay, so this helps in graceful handling of the request instead of simply crashing them. So another middleware example is this authentication, which as you can say, it basically does the authentication where it takes the token and adds some. It's like a fake authentication here, but yeah, it does this authorization checks. Here it compares whether it got the correct token or not. If not, it gives an error. If yes, then it is fine, and it passes on to the next one. And similarly, we have this rate limit one as well. Okay, so now I'm going to run the code. It's actually running here. I have done go run main.go, and here are these commands to try. Okay, so let's say first I'm trying this public endpoint. Okay, so I have executed that, and here you see what happened. Here the request ID got hit in the chain, then the logging got hit, then the recover got hit. Okay, and then the public handler got reached, which is the final handler, and then we do the opposite: the recover, then logging, then request ID. Okay. Similarly, if I do the private one, here I'm doing the private one without any authentication, so I'm seeing unauthorized, which is expected. And here you see yeah, logging, recover, enter, but then authentication basically failed, so the chain stopped here. So then it exited, and the recover got hit, which got exited, then the logging, and then we went back to request ID. Okay, let's try this with an actual bearer secret as the authorization. So now the private endpoint is fine because auth worked fine here, because the token is valid according to the logic that was written, and the rate limited finally entered into our discussion, so the rate limit is fine as well. And then we went again backwards, and then this is how the entire sequence of things looks like. Okay, so this is a very brief example of the chain of responsibility pattern in Golang.